All right, get ready, because today we're going deep into quantum mechanics.
Ooh, exciting.
Yeah, specifically, there's this paper, it's called Quantum Leap, Innovative Breakthrough in Entangling Light and Sound. It's from the Max Planck Institute.
Oh, yeah, I saw that one.
Yeah.
Really interesting stuff.
Yeah, so they've managed to entangle light and sound, which
It's just wild.
it's pretty crazy.
Totally theoretical until now.
So entanglement,
Yeah.
that's where two particles are linked, right? Even if they're super far apart.
Yeah, exactly. So, like, if you know the state of one,
You automatically know the state of the other.
instantly. Yeah. And this is, like, fundamental to
That's a big deal.
a lot of quantum technologies we're looking at for the future.
Right, like secure communication and
Super powerful computers.
yeah, all that crazy stuff.
Things that could, like, totally change everything.
Okay, so what makes this research different? Because I feel like we've been hearing about entanglement for a while now.
Right. Well, the key here is that they're using sound. Yeah, so, like, previous attempts at entanglement have all been focused on photons.
Those are the light particles?
Right, exactly.
Yeah.
But this research has managed to entangle those photons with phonons.
And those are the sound wave particles?
Yep.
Okay, wait, so using sound, that's...
It's pretty out there.
Yeah, why would sound be better than light for this?
Well, it turns out that sound waves, or phonons, move way slower than photons, which you might think would be a disadvantage, but it actually gives the particles more time to interact with each other.
So they have more time to, like,
Yeah.
get to know each other and form that bond?
Yeah, exactly. And so this creates like a more stable, entangled state that's less likely to be messed with.
Oh, so it's more robust.
Exactly.
Yeah.
Way more robust.
Okay, so I'm starting to see why this is so groundbreaking.
It's huge.
Yeah, but one of the things I always hear about with quantum computers is that they're really hard to build, right?
Yeah, they're still mostly stuck in labs.
What's holding them back?
Well, one of the biggest things is temperature. Most quantum experiments need incredibly low temperatures to maintain that entanglement.
Like close to absolute zero.
Yeah, we're talking crazy expensive cooling systems.
Yeah.
Totally impractical outside of a lab.
So how does this new research with sound change that?
Well, this is where it gets really cool.
Okay.
This new method works at much higher temperatures,
Much higher. Like, what are we talking?
tens of Kelvin instead of a fraction of a Kelvin.
Okay, so to most people, that still sounds ridiculously cold.
Yeah.
But in the quantum world, that's a massive difference, right?
Oh, it's absolutely huge, like game-changing. It basically means we could integrate quantum tech into everyday devices.
Whoa.
Like, imagine quantum computers running on ships.
In our phones and laptops.
Exactly.
Okay, now I get why they called this research a quantum leap. But I'm still trying to picture how it all works.
Yeah.
How do you entangle light and sound in the first place?
They use something called Brillouin scattering.
Brillouin scattering.
Basically, the light and sound waves are like exchanging energy as they travel together. And at the quantum level, this energy exchange links the photons and phonons, entangling them.
So they're like doing a little dance and then holding hands.
Yeah, that's a great way to put it. And because they're entangled, even if you separate them, if you do something to one particle, it instantly affects the other.
Wow, no matter how far apart they are.
Exactly. That's the spooky part.
That's crazy. Okay, this is already blowing my mind.
We're just getting started.
And we're just getting started.
I know, right?
Welcome back. We're in the middle of this incredible research about entangling light and sound.
Yeah, like game-changing stuff.
I know. It could totally redefine quantum technology.
Absolutely. And you know what's amazing? They're using sound to like make entanglement better and more stable.
Yeah, no, it's wild. Okay, so before we get too deep in the weeds here, let's do a quick recap for anyone who's just joining us. We're talking about this new method for entangling photons, which are light particles, with phonons, the sound particles. So remind us again why this is such a big deal.
Well, like the traditional ways of entangling photons, they've always been super delicate.
Oh, yeah. You need those crazy low temperatures and all the specialized equipment.
Yeah, and it's really expensive, too.
So that's where this new method with sound comes in.
Right. It's a total game changer.
It changes everything.
Yeah, because using phonons lets entanglement happen at way higher temperatures.
So we're talking like tens of Kelvin.
Yeah.
Instead of being super close to absolute zero.
Exactly. It just opens up so many possibilities.
So instead of having these massive quantum computers that need to be kept super cold, we could have quantum devices that operate at, slightly less insane temperatures.
Yeah, exactly. Like temperatures that are a little closer to, reality.
Yeah, more practical.
Exactly. We could start putting quantum tech into the stuff we use every day.
Like our phones.
Yeah, like imagine, quantum processors in your phone.
Or using fiber optic cables to send information that can't be hacked.
Exactly.
Okay, now I really see why this has so much potential.
It's huge.
But how do we get from these exciting results in the lab to actually building devices that work?
Yeah, that's the big question, isn't it? It all comes down to scaling things up and making the technology better.
So what are some of the biggest challenges you're facing?
Well, one of the big ones is fabrication. Right now, the experiments they're doing just involve a small number of particles that are entangled.
Right.
But if we want to build devices that people can actually use, we need to figure out how to reliably create and control entanglement on a way larger scale.
Okay, so it's like having a prototype, but then figuring out how to mass produce it without losing any of the precision or stability.
Yeah, exactly.
Yeah.
And that means we need some serious advancements in, like, materials, science, and engineering.
I see.
We need to find new ways to make these photonic devices that can handle huge amounts of entangled particles.
Right, and I imagine integrating this kind of tech into our existing infrastructure is its own challenge.
Oh, yeah, for sure.
We're talking about putting sound-based entanglement into things like fiber optic cables. Like, how do you even begin to do that?
Yeah, it's a tough engineering problem, but people are already working on some really promising approaches.
Oh, wow.
Like, one idea is to use these tiny things called microresonators inside the fiber optic cables themselves.
Microresonators. Okay, help me picture this. What are those?
So basically, imagine these tiny little chambers where the light and sound waves can interact and get entangled.
Oh.
Yeah, they're specifically designed to trap and control those waves.
That's interesting.
So we can maximize their interaction and make the entanglement process even stronger.
So this is where physics and engineering really have to work together.
Exactly.
You need to understand the quantum mechanics, but you also need these really advanced engineering skills to design and build these tiny devices.
It's a perfect example of how different areas of science can come together to make something new.
Yeah.
And it shows how progress in quantum tech isn't just about these big theoretical breakthroughs, It's also about, like, pushing the limits of what's possible in material science and engineering.
I mean, this is a perfect example of that, this deep dive.
Right.
We started out talking about quantum entanglement, and now we're talking about microfabrication and advanced materials.
It's all connected.
Yeah, it's incredible, and it feels like we're just getting started.
Oh, absolutely. This research is like opening a whole new frontier.
So what are some other potential applications for this technology?
Well, one area that has people really excited is quantum sensing.
Quantum sensing.
Yeah, so by using the fact that entangled particles are super sensitive, we could build sensors that can pick up on even tiny changes.
Like changes in what?
Like in gravity or magnetic fields, even things happening in biological processes.
Whoa. So we could revolutionize everything from navigation and exploration to healthcare and environmental monitoring.
Exactly.
Yeah.
And because this new method lets us do entanglement at higher temperatures, these sensors could be smaller, more portable, and tougher.
So we could use them in even more places.
Yeah, exactly.
I mean, this is incredible. We've only just scratched the surface of what we could do with this new discovery.
It really is amazing. It's like this ripple effect where every new breakthrough opens up even more possibilities for exploration and innovation.
And that's what I love about science.
Yeah.
Each new discovery leads to something even more amazing.
Exactly. It illuminates the path forward, leading to advancements we couldn't have even imagined and a deeper understanding of the universe.
But let's talk about what this all means for, everyday people.
Yeah, that's a great point.
Because not everyone is a quantum physicist.
It's easy to get lost in all the technical details, but we have to remember that this research has the potential to really change people's lives.
Okay, so tell me about the practical applications. What's in it for me?
Well, for starters, imagine your smartphone having a quantum processor that could do calculations that would be impossible for even those powerful computers we have now.
So we're talking about solving huge problems in things like medicine and AI.
Exactly, right in your hand. And with this unhackable quantum communication, we could keep all our data and online conversations totally private.
It's like science fiction is becoming reality.
It really is. It's such an exciting time to be alive, to see this new technological era being born.
But like with any powerful technology, you have to be careful, right? We need to think about the ethical implications as well.
Absolutely.
Yeah.
We need open and honest conversations to make sure that these advancements are used to help everyone.
Well said.
Thank you.
I mean, this deep dive has been a journey.
It has.
We've explored the crazy world of quantum entanglement.
I know.
We've talked about this groundbreaking research, and we've even considered what it might mean for society and the future.
It's been a pleasure talking about all this with you.
So before we move on, is there one key takeaway you want our listeners to remember?
The future is not set in stone. It's made by the choices we make right now. So by staying informed, having thoughtful conversations, and supporting responsible innovation, we can all help guide the development of quantum technology so that it benefits all of humanity.
That's a powerful message.
Thank you.
So thank you for joining us on this deep dive into the quantum realm.
It's been fun.
Welcome back to the show. It's been quite a ride so far.
It really has.
Exploring the quantum world and this incredible research on using sound to make entanglement more practical.
Yeah, it's amazing how we can manipulate these tiny particles to connect over huge distances. It feels like we're living in a science fiction movie.
I know. But as we've been talking about, this isn't just theory anymore. This research is leading to real-world applications that could change our lives.
Absolutely. And as we move into this new era of quantum tech, it's really important to step back and look at the bigger picture.
The bigger picture.
Yeah, like what does it all mean for society? What are the implications of these advancements?
Right. It's not just about the science and engineering. It's about us, too.
Exactly. We need to be thinking about ethics, potential risks, and how to make sure this technology is used responsibly for the good of everyone.
So let's talk about that. What are some of the ethical questions we should be asking as this technology keeps developing?
Well, one of the biggest worries is that it could be misused. Imagine if quantum computers become powerful enough to break all the encryption we use to protect our financial information, our personal data, even national security secrets.
That's a scary thought.
It is. It makes you realize how important it is to have safeguards and regulations to keep these technologies out of the wrong hands.
Yeah, absolutely. We also need to think about the potential impact on jobs and the economy.
Right, as quantum computers get more advanced, they could start doing jobs that are currently done by humans.
Leading to job losses in certain industries.
Exactly. So we have to start thinking about how to prepare for these changes.
Like maybe investing in education and retraining programs to help people adapt to the changing job market.
Exactly. And another thing is access and equity. We need to make sure everyone benefits from this quantum technology.
And that it doesn't just make existing social and economic inequalities worse.
Right. It's a complicated issue, but it's one we need to face head on.
Okay, so we've talked about the potential risks and challenges, but let's not forget about the incredible opportunities this technology presents.
Oh, for sure. Imagine a world where we can create personalized medicine tailored to each person's genes, design materials with properties we've never seen before, or model complex systems like climate change with amazing accuracy.
It seems like the possibilities are endless. It's like we're on the verge of a brand new scientific revolution.
And remember, this revolution is happening because of human ingenuity, our curiosity, and our desire to understand the world.
It's amazing. This deep dive has been such an incredible journey. We've explored these mind-bending concepts of quantum entanglement, learned about this groundbreaking research, and even talked about the impact it could have on society and our future.
It's been great talking about all this with you.
So as we wrap things up here, what's the one key takeaway you want our listeners to remember from this conversation?
The future isn't set in stone. It's shaped by the choices we make today. So by staying informed, having open discussions, and supporting responsible innovation, we can help guide the development of this technology in a way that benefits everyone.
That's a great message to end on. Thanks so much for joining us on this deep dive into the quantum realm.
It's been a pleasure.
That's it for this episode of The Deep Dive. We'll be back soon with another fascinating look at the cutting edge of science and technology. Thanks for listening.